Welcome to the Digital Forester Podcast, where we talk to foresters about how they are using digital technologies in their day-to-day forestry work. Hey, everybody. Welcome to the Digital Forester Podcast. Today, I'm joined by Dr. John Lindsay. He's the co-founder and CEO of Whitebox Geospatial. John, how are you today?
I'm doing well, Kevin. Thanks again for inviting me today. It's a pleasure.
Yeah, thanks for joining. So right off the bat, if anyone was to look Dr. John Lindsay up, they would probably find a Dr. John Lindsay who's a professor at the University of Guelph. So maybe to address not the elephant in the room as a negative context, but you do have almost like a twinsy life, I suppose. Maybe tell us about what you do on the research, the academic side, and then we'll shift into Whitebox Geospatial. So what do you do at the university? Which university?
Sure. Yeah. So as you mentioned, I am a professor of geomatics at the University of Guelph, where I've been since 2008 or so. And so I kind of have, as you said, these sort of two existences, one born of the other, I suppose. And so my day job is, of course, as a full-time professor. I teach, I do research. My research area is essentially geomorphometry. And geomorphometry is, I like to think of it as understanding landscapes using digital terrain and or digital topography. And so born out of that comes a desire to create sort of innovative solutions for analyzing geospatial data. And the platform in which I do that is the software that I've developed over a number of years called Whitebox. And so more recently, since 2021, June, we launched a company to support that software since that project sort of grew over time.
Very cool, very cool. So for our listeners and viewers, I went to the University of Guelph for undergrad. The university is close to my heart, and the building I know, John, you're in. I've spent many moons in there, probably toiling around since it was undergrad. But awesome to connect. And at the same time, I think in terms of our graduate studies, we're very similar in terms of I'll say era now, because on LinkedIn I was looking at your profile and I thought, wow, like John's a professor already. And then I looked further, I was like, 16 years at the University of Guelph, and I thought, wow, how time has flown. But yeah, so definitely interesting there. So we'll put the university side, the work aside for now. I was glad you introduced geomorphometry, or maybe you could say it again, because in my mind, geomorphology, and then I was like, did I write this down? So at least you defined it. So very much the science, the analysis of terrain models and how they can be used for data analytics. So thank you for clarifying that. And so I'm really curious to know your journey, because as a professor, you're busy, you're teaching, you're researching, you have a bajillion and one students knocking on your door with all those great questions that I know professors love to field, which are probably, can I get an extension on this assignment per se, or is the exam really next week? How can it be? But the first question I have is, where did this idea of Whitebox really come from? Because I believe it's open source technology. So is there a story there in terms of some spark or some connection with the open source community?
Yeah, so I mean, ever since my undergrad, which was actually not at Guelph, it was at Nipissing University, I've had an interest in GIS, and in particular open source GIS. And I don't know, coming into my graduate research, for various circumstances, various reasons, I found myself having to develop novel solutions to address problems in my research. And that's where I first started to develop my own sort of open source GIS platform, I'd say. In the early days, it wasn't Whitebox. So Whitebox came about when I transitioned from my position where I originally taught at the University of Manchester to University of Guelph. That's when Whitebox emerged. And the current flavor of what I now call WhiteboxTools, this open source geospatial analysis software, it's kind of back-end software. It started in 2017. I was looking earlier today, actually, in prep for our conversation, and the first commit that I had for WhiteboxTools to GitHub was early 2017. And I thought to myself, well, that's strange, because I remember announcing it publicly like towards the end of 2017. And I realized, oh, that's because I spent the first many months writing it before I had like a public ready release version to announce. So it was towards the end of 2017.
Yeah, so when you talk about commits, obviously you're writing code, doing technical stuff, but is that your training or your academic studies? And if not, where did that come from like that? Because it's technical, like, and we'll talk about it with the tools. There's a lot of very sophisticated tools there that I suspect some, pretty good comp sci or computer science people couldn't even do that type of work. And you're doing it on the side as beyond your duties as a professor. So where did that like, were you always a developer programmer since you were a kid, or
No,
something
no.
you picked up? No, okay, tell me more.
Well, yeah. So I didn't start developing until my PhD. Um, it was during my PhD that I first started to, as I say, encounter geomatics problems where the sort of existing tools that were available in the GIS that were around me, they simply couldn't solve the types of problems that I was working on. And so I started programming out of necessity, essentially. And during that period of my PhD, I was engaging a lot with the research and seeing sort of what innovations were in various areas, and getting excited about the opportunity to develop my own sort of solutions to these problems, and that's where coding came to me. So I'm not a professionally trained coder at all, which if you review my code, you might well agree with. I don't know as though I'm the best coder by any means, but yeah, I've over the years picked up a fair amount. I've been doing this now for about 20 years or so, and in that time, I've certainly learned a lot. It's not so Whitebox Tools is not my first sort of attempt at coding this type of program. Out of my PhD, it was called the Terrain Analysis System, or TAS, and it was freely available, but it wasn't open source. And in large part, it's because I was brand new at programming, and frankly, my code was a mess. It wasn't something I wanted to share with others. But as it grew in its user community, people started to ask for the code, and so at some point I decided, okay, well, I'm going to have to start new, and started an application called Whitebox GAT, which was a desktop GIS, Whitebox Geospatial Analysis Tools, and it was open source. People could see the code. It was developed in that case in Visual Basics .NET and C#, combination of them. And so yeah, that was my second try, and I got better with that. And then Whitebox Tools is my third try. It's developed using the Rust programming language, and at this point I'm a lot better. So when you see tools that are in Whitebox Tools, many of them have earlier versions that I had written in previous versions of software, and I've just learned to improve as I've learned and grown as a developer.
Yeah, very cool. So it sounds like you've iterated on a couple different versions or flavors, and now you've largely settled on that where you are now. So I'm curious, for some of our listeners who are technical, they'll hear Visual Basic, .NET, C#, and they'll understand what that means. But I know when you mention Rust, that's probably some people are going to be scratching their heads wondering, was that like a bad internet connection and John said something else, or like R and it became Rust? But tell us more about what Rust is.
Oh, don't get me started on Rust. I love this programming language. So, I mean, over the years, I've probably learned a dozen or more programming languages. And so the transition from Whitebox GAT, the desktop GIS that I was mentioning, to Whitebox Tools came as a result of me hitting a wall. So as I said, the very first version of Whitebox GAT was written in .NET languages. And when I first released it, people said, this is great, but we'd like it to run on like Linux and Macs, and it only runs on Windows. And so I actually went back to the starting board, and I actually started to write it in Java. And with those various languages, I kind of hit a barrier very quickly. I mean, our field, we're dealing constantly with very large data, which means that it needs to be very performant in terms of memory and in terms of its computational performance. And Java was really causing issues for me. And so I spent a lot of time evaluating many different languages when I started the Whitebox Tools project. And after about a year of evaluating many of the different systems programming languages and newer languages that have emerged, Rust was the one candidate that checked all of the boxes. And Rust is an amazing language. It is, I think, it is the most loved programming language by, it's been voted that way for the last, I think, 5 or so years now by developers. And it's because of the many advantages that it offers for things like programming in geomatics. It's not an easy language. It's a systems programming language, which means that it would be the same kind of language you could write an operating system in, which means it needs to be pretty low level. You need to be able to have really fine-grained control over memory and over resources. And it needs to be very fast, very, very fast, like sea levels fast. And there aren't a lot of programming languages that are in that sort of domain. C, C++, Ada, there's a few others like that. Fortran, I suppose. And Rust is the newest one of these. It came out in, I might get this wrong, but somewhere around the sort of 2010 or so period. And it was originally created by Mozilla, the people who make the Firefox browser. And it is truly, because it's a modern systems programming language, it's got a lot of characteristics that are just really optimal for this. There's no garbage collector, for example. One of the reasons that, C#, Java, Python are slower is because you don't really have control over the memory. And so, there's a garbage collector that instead decides, it's like a program that runs alongside or in parallel to your program and says, oh, okay, are you done with that variable? I'll clean it up now. And with Rust, there's nothing like that. Rust, it's all done at compile time. At compile time, it does a real thorough check of your code and says, oh, okay, you're done with this little bit here. I'm going to free that bit of memory at this point. You're done with this here. I'm going to free it now. So it's quite remarkable. It's the only programming language I know of that really does that. C and C++, you have to do it manually. And if you don't get it right, then there are all kinds of security vulnerabilities. It's one of those reasons that your Windows machine constantly wants to do updates as these security vulnerabilities get identified because of these types of things. So Rust, again, I'm very enthusiastic about it. And while there aren't a lot of people right now programming in Rust compared to some of the other languages that we deal with commonly, it is, in my opinion, one of the most innovative and interesting languages in the landscape.
Yeah, very cool. Just as you started describing it, I could see this spark kind of jump in you when you started talking about Rust, and I've heard about it more recently from hardcore developers, and so was curious to see your view on it, because definitely, as we'll talk more about it, your whole world is large volume data sets, and if the software don't work, or it's going to take eons to compute, then obviously that's not going to work for people. I'm curious to know, I'm gonna ask some of the usual questions that I'm sure you've been asked a bajillion times, but our listeners also know I'm very good at asking the quote unquote dumb questions. But open source, closed source.
Mm-hmm.
What's your views on that? Does it really matter, or is it more about building high quality tools and philosophically, if you're in the open source camp, making them available through those types of licenses, and closed source, so be it. They're available, you can pay for them if you'd like, but do you have a certain position on open source versus closed source?
Well, I think I do, and I think that position has evolved over time for sure. So I am definitely an open source advocate. I love open source software. I love the fact that it exists and that people contribute to it in the communities that build around it. We've said that Whitebox Tools is open source, and that's true. There are, because we've formed this company around the idea of being able to support the Whitebox user community, obviously the company needs to generate software. And so we have created extension products that we sell, which are in fact closed source, in the support of the open source core. Whitebox Tools, essentially, as the project developed over time, it built up quite a large user base, and that community, of course, takes resources to support. And so I got to a point where, as you mentioned earlier, I'm a full-time professor, and a full-time professor, as any professor will tell you, it's kind of like 3 jobs in one. It's not something that can be confined to a normal number of hours for any sort of job. And so to have on top of that, and the responsibilities that come with that, the large amount of time that it took to support the user community that had grown around Whitebox Tools, we needed to form a company in order to have additional human resources to help the user community and to invest really strongly into that open core of Whitebox tools. And so, we very quickly realized, we're going to need to sell something. And so, I've developed a set of, I think at this point, close to 70 or so tools that are not part of the 460 or so, 470 tools in the open core. They live outside of the open core. They're closed source, and we sell those tools. We also have a product that's based on the open core, but it's specifically a Python extension module. So Whitebox Tools is a back end that multiple front ends can speak to effectively. Like there's a front end for QGIS, which is quite popular. There's a front end for R and Python and ArcGIS. But it's essentially a standalone command line operation in terms of the binary that is Whitebox Tools. And so the Python front end for what the open core, it's sort of a thin wrapper of Python that speaks to this binary. So I've developed a Python extension module that more intimately allows conversations between your Python script, your geoprocessing script, and the Whitebox Tools front end, and we sell that as well. So in terms of closed source, I think it's necessary in some cases. It can help, as is the case with Whitebox Geospatial, it can help to create a healthier environment around open source software. It can help to contribute. I mean, that's the sole function of our company, is to try to foster a sort of a healthy vitality around the open core of Whitebox Tools.
For sure.
Yeah, big open core fan for sure, but I realize that there is a need always for closed proprietary software for sure.
Yeah, I love that in the sense that it's not one or the other. I love how you described that. So I also took away that, hey, if I'm using the open source tools, that if I email you directly at your email address, I shouldn't expect like a response in 30 seconds, even if it's me, Kevin, reaching out to John. I need help with this tool, and I'm saying that in jest. But maybe with the tool set, we've kind of talked a little bit. I know you've talked about the core and the extensions. So maybe for our listeners who are Digital Forester listeners, they are often ArcGIS users. They are using QGIS. So what I heard from you is don't look to the Whitebox tools as your I don't know, primary GIS or visualizer, but look at it more as a back-end data analytics engine that you might hook in to do different things. Is that an accurate, well, probably a terrible description of your product, but it's not a full-blown GIS. You wouldn't look to the tool set to do the 3D visualizations, all that. Would you, or would you not?
Well, so like I said, Whitebox GAT was a desktop GIS. It was a full-blown GIS. And Whitebox Tools came from a realization that a lot of people really came to Whitebox and loved Whitebox because of its set of tools, and not necessarily because they could use it to visualize their data. They already were using ArcGIS or QGIS at that point. And so I realized, well, I'm putting a lot of effort into developing this wonderful front end that I love, and some people do love, but a lot of people just want to be able to access those tools from their existing GIS. And so that's where Whitebox Tools as a project came about. It's a backend. It truly is a backend that's intended to be plugged into other software like QGIS and ArcGIS for visualization. But you say, is it a general GIS? Well, I mean, from the perspective of the tools that are available in something like QGIS or ArcGIS, I think it's probably not far off. I mean, its applications are very, very wide. It does everything from, vector data analysis to, LiDAR data analysis, remote sensing analysis, general GIS operations like buffering and everything you would expect to find. It's sort of like ArcGIS in a nice little sweet package that you can just plug into whatever front end you want, or use from scripting languages like R and Python.
Yeah. Well, it's kind of funny as you described that, John. It'll probably date us, but going back to the GRASS GIS days, it almost sounds like, if you want to go command line, then yeah, it's a full GIS because it does all this sophisticated analysis. But maybe you're not going to use it for a 3D fly-through scene, and you might use something else for that as an example.
Visualization is not its intended purpose by any means.
Yep. Right, for sure. So I guess thinking of a user, their best entry point is saying, hey, I'm going to use the WhiteboxTools Open Core, which is open source, and there's over 460 functions or modules, I believe. I'm not sure if I'm using the right terms, but 460 things that are available for free for anyone to use. And then beyond that, then on the paid side, what I've heard is that there's the extensions and even workflows for Python. And there's a pro version, I even believe, looking at the website. And these are not big dollars, to give our listeners a context. And this is from your website, John. So hopefully they're still accurate and I'm not putting it on the spot. But we have things like that are $10 a seat for the workflows for Python, I believe. And then if you go to the pro level, you're talking $350 US per year for a user, and then it drops to $60 a user for any additional users. So these are not like big sums of money, right? So when you say, hey, it's like we wanted to monetize this and support the community, these aren't big sums. So does it make sense? Like, how big is the Whitebox Geospatial team now, and what size of community over the years is it supporting? Because I'm going to guess it's probably a massive community.
Yeah. So, I mean, those are excellent questions. We are a really small company. I mean, it's just myself and my co-founder, Anthony Francione. That's it. As I said, you know, I'm paid full-time as a professor, so I don't really draw a salary from the company. We're not aiming to grow into a massive $1 million company by any means. We really are just trying to create the best software that we can to help people to solve the problems that they're working with in day-to-day, and really just trying to support that open core. So yeah, the prices are low, and the prices are low quite intentionally. We're really just trying to generate enough revenue to meet our objectives, essentially. And obviously growth is an important thing for us. We want to grow like all companies do, but we don't have the sort of Esri picture at the end of the day in terms of the scale that we're growing to by any means, anything like that. And we're just a small company. And the community is large. It's quite large at this point. And so, you know, earlier you described, you know, if you send me an email, am I going to expect a 30-second reply? Well, you know, that describes a lot of my day. You know, every day I open up my email and there's people who contact me and say, you know, oh, I'd like to be able to do this, or I've used this tool and I'm curious about whether it can be applied in this way, or I've run into this error. How do I get past that? And that is, you know, a big part of my day and Anthony's day in responding to those, because the community at this point has grown so large and it's so global. You know, a survey that we did a while back showed that we're being used in something like 173 countries for one survey. So it's quite widely applied. And, you know, I think a large part of that is because of the functionality, which is sort of extensive, particularly in certain areas like LiDAR analysis, and the fact that it's free or very cheap.
Yeah, very, very cool. So maybe for our listeners and viewers, some may be sitting there saying, okay, you're talking about this product, but what does it really do? And I suspect some of them may still be listening because they're thinking it's open source. I want to learn more, right? It's free. I gotta see. And some may never have even heard of this product. But maybe for our listeners, what are there maybe top 3 use cases that you see over and over again in terms of how people are using the Whitebox platform, whether I'm assuming it's used for academic work, but I'm assuming it's also used for commercial endeavors. But are there maybe top 3 use cases or scenarios that you see consistently repeating, or questions that are coming related to that? You mentioned LiDAR, so I'm going to assume, and given the area of your research, I'm going to assume LiDAR and terrain is probably one of them.
Sure. I mean, that's definitely the case. So LiDAR makes up, I think about half or so of the users are coming to it from a LiDAR analysis perspective. Spatial hydrology as well is one of the common application areas. Forestry makes up about 20% of our users, I think. Again, this comes from an earlier survey that we did where we asked people, hey, what are you actually using it for? What are you applying it for? And it was about 20% of users who are applying it in the forestry area. Agriculture, conservation, those also are areas that it's pretty widely applied in, and remote sensing. Not coincidentally, some of the areas that I teach in. I've added a lot of functionality around the things that I teach and that I do in terms of research. And oftentimes that functionality is somewhat unique. Things that you won't necessarily find in other software, and that tends to be the thing that draws people in. While I said it's a general GIS in terms of having functionality for vector data analysis, buffering, whatever, those are things that you can find in other packages. So it's the unique offerings that we have among those 400 and whatever number of tools in the open core that people are coming to it for.
Yeah. So thinking, you mentioned forestry at about 20%. That's higher than I thought. So obviously there's more people that are tapping into the platform. But can you give me a sense when you say, we've developed this technology, we're coding in Rust, it's super fast. Can you not quantify, but maybe storytell or describe me what does that really mean? So often if you're on the Canadian side in forestry, you're dealing with 1 million hectares. If you're stateside, you might be dealing with, I don't know, 200,000 acres. But when you say fast, and this thing is like, and I believe you, don't get me wrong, but for our listeners and viewers, I'm just wondering, what does that really mean? Is this set it and forget it and come back in a week? Or is this thing so high performing that it can multi-thread or do parallel compute, or what's an example you can give me to convey how speedy this open core is?
So, I mean, that's kind of a hard question to answer for a number of reasons for me, because obviously it depends on the application. And I'm not so much an application guy as I am I'm not so much on the application side as I am on the development side in terms of geomatics. So, I mean, I can tell you experiences that I get in terms of people contacting me. So a week doesn't go by where people don't contact me and say, thank you very much for these tools. And the comment that they always say is that it's incredibly fast. Like I don't expect it to be fast to this level. I've had, for example, one person who was processing all of Australia. So it was I think a 30-meter DEM for the entirety of the Australian continent. And so they set it up on their computer. It was, mind you, obviously a very, very powerful computer. But they said they went off for coffee. They assumed that they'd come back, like the next day and it would still be running, but it was done by the time they came back from coffee. So, I've programmed this thing to be fast. Like whenever you create code, as you well know, you have certain compromises that you have to make. And the big compromise is memory versus speed. And, you can address that compromise in a number of different ways. But when it comes to priorities for developing Whitebox, speed is always number one. I'm always thinking, how do I make this algorithm faster? And one of those things is choosing a really performant language like Rust, and another one is obviously creating the most performant algorithm you can to solve any particular task. And another is to make that algorithm as parallelized as it can be. And so I have, those are the things that I do in developing tools for Whitebox in order to try to make it extremely performant. And it's true, it scales very well to large data sets. It will scale to eat every one of those processors, those cores that you have available on your system for many operations. When I say that it's parallel, as you probably well know, there are certain operations that simply can't be easily parallelized. For example, in spatial hydrology, there are several types of operations where you need to solve things sequentially, and so it doesn't lend itself to being parallelized, which isn't to say that it isn't performant in those areas. It's still very, very performant. But I've parallelized basically everything that I easily can parallelize. I have done so in Whitebox tools. So if you've got, as I do, say a 16-core machine, I'll often see it running at like 1,600% as those cores are burning away on processing a particular data set. It's not uncommon at all, and so yeah, it's pretty darn fast.
Yeah, for sure.
We processed, for example, the entirety of for many of our listeners, they won't necessarily know, but I'm sure you do, the Lake Erie watershed data set for southwestern Ontario. And that is a massive data set, just massive. And I process that on my Mac desktop sitting right here, actually, that I'm looking at. So it's just a sort of an average desktop in truth. And I processed the entire data set in about 2 days or so. And that included things like ground point filtering, interpolation, and then the post-processing of the DEM. So mosaicing each of the individual tiles together, performing hydrological analysis, so depression filling or breaching, and then extracting of various LSPs or land surface parameters like slope, curvature, etc. On a pretty damn large data set for sure.
Yeah, very, very cool, very cool. Yeah, no, thanks for sharing those examples. And I will tease our Aussie friends, we know how they love coffee. So if they're going for coffee, we don't know if that's 15 minutes or 4 hours based on my travel experience.
That's true. It could have been 2 days for all I know.
Yeah, exactly. So we're just joking, of course, there. So very cool. And just for the nerd in me, we're talking about parallelization. That's a word that always is a tongue twister at the core level. But on the GPU sides, if we've got a kick-ass graphics card, is the platform, Whitebox platform, also leveraging those where it can?
So that's an excellent question. And here I have sort of a sad reply for you. So the answer is no. It will use all of your CPU cores, but it won't do any GPU processing. And the reason for that is a couple of things. So first, GPU programming is very specific to the GPU. I don't know if you're familiar with this or not, but whether you have, say, an AMD or an NVIDIA GPU, like they're different things. You need to write software for one of those things, kind of thing. And so with Whitebox, I've always sort of strived at creating software that can be used by the most number of people. And when I'm envisioning who's using my software, in truth, I always in my sort of back of my head have someone sitting maybe in a conservation authority office on a computer that's 10 years old and not particularly powerful. That's the person that I'm writing code for. It's the reason that I try to write code as performant as I can. And so I can't write code where it requires someone to buy a specific type of computer with a specific type of hardware. And then also one of the disadvantages, I suppose, of Rust, and I might well get in trouble with Rust development people at this point, but it's a new programming language. And I don't think that the GPU programming story of Rust is fully fleshed out at the moment. And so there haven't been as many opportunities for me to sort of explore that GPU space. So right now, while I say it's parallelizable, and it definitely is, it's going to use all of your CPU cores, not so much your GPU cores. Yes. So that might disappoint some people, but I can tell you it's give it a try. It's surprisingly fast.
Yeah, but at the end of the day, you and I both know it's cores. Like we can add lots of cores in very cost-effective ways. So fast as fast can be there. So I know this is about the digital foresters, and I know when you and I were connecting, one thing was, well, I'm not sure if I'm going to have a lot of forestry stories to tell, but I also felt it was important for the forestry community to be made aware of the tools you develop, because nowadays, as you mentioned, 20%, I guess, of your community are foresters. LiDAR is the rage, whether it's linear mode LiDAR, whether it's Geiger mode LiDAR, whether in Ontario where we're based, it's single photon LiDAR. And as we look at some of the newer technologies, I don't know if they're really that new, but the single photon and Geiger mode LiDARs, they're creating way more points than we're even used to. So that high performance becomes even more important. And so I'm thinking with your work, I know before we came on this pod, this is kind of funny for our listeners, kind of two nerds talking to each other. You started working on something and literally just got it done. And we agreed we're going to show some people. So for our listeners and our viewers, we're now starting to get guests on the podcast. We might have to change the name of podcast, but folks want to show things and let people visualize. So we're going to take a little sidebar, if that's the right word to use, and we're going to talk a little bit about a little project you just spun up, and we're going to show what that looks like, just to communicate the power of the platform and the unique technical skill set that you have, your ninja skills. So why don't you describe to me, because again, we haven't talked about this. We're totally going on the fly. Well, actually, everything on the podcast is done on the fly. But what is it you wanted to share? You're dealing with a LiDAR data set. You're using our library, and then you kind of did something. But maybe walk us through what we're seeing on the screen and what you did.
Sure. So, I mean, as you said, before we talked about doing this podcast, I, sort of relayed concerns that I don't really work in terms of my own research area very much in the forestry space. And while there are definitely users of Whitebox in forestry, I know that for sure. Well, it's not an area that I have a tremendous amount of expertise in. Well, one of the Whitebox users reached out a couple of weeks ago on Twitter and said, "Oh, hey, is there any chance that you could implement some of the tools for extracting, some of the common LiDAR point features for trees, for forestry that are widely applied in forestry?" And so that got me thinking and got me exploring some of these metrics. And so literally right before we met to record this podcast, I just finished off the first of a series of tools that I'm hoping to add to Whitebox. And this one is for identifying individual trees. Not segmenting yet, that'll come, segmenting trees in the point cloud, but this is just to identify the points in a point cloud that are the tops of trees effectively. And this comes from having looked at some of the things that are done in the wonderful R LiDAR library, LIDAR. I'm sure the viewers here know what we're talking about in that regard. So anyhow, it's always kind of nerve-wracking giving a demonstration of a tool that you literally just wrote, because something could go wrong. But I'm hoping you can see my screen at this point. Is that?
Yeah, absolutely.
All right, so we have Whitebox Tools here. This is the plugin for QGIS. Same thing. I'm not sure if you can see this as well, but this is the Whitebox Tools runner, and similarly, tools can be there because again, it's just a backend. But if I go into the LiDAR, so this is hot off the presses here, but I have the individual tree detection tool. And let's just give a bit of a demonstration so we can see everyone how it is that this, how Whitebox works effectively. So if I take, it's called normalized LAS. So this is a LAS file. Can you see the QGIS dialog for the tool?
No.
No, you can't. Eh? I always wonder when I share my screen if that's going to be the case or not. All right, hold on here. Let me just quickly. So
this is the fun, folks, when you do live demos that are unscripted. We love it on this podcast.
When you share your screen in Zoom, sometimes like it doesn't share the pop-ups from you just share your application and not the pop-ups. So,
well, hey, at least you get to sharing the screen. This guy forgets to actually click the share button the second time. So often I'm talking and someone has to say, you're not sharing your screen. It's like, oh, so sorry. Since I'm programmed to use Teams. And I'm sure a lot of you listeners are chuckling because you've all been there.
Well, Teams I'm more comfortable with. I think I got to solve this problem on Teams, but Zoom, I'm not quite there yet with. Hopefully you see this pop up now. So these are, I just ran the tool. It took about 15 seconds to run. Wow. And so I've just overlaid it on a digital surface model here, just so that, but it is actually, it's performed on the point cloud. So it's a LAS file that I input for this, and I'll just make this. There we go. So the idea is to identify, the tops, the very tops of individual trees within the forest. So you can measure things like point density, obviously, and so this is just a single tile. It's from a LiDAR tile in New Brunswick. The province of New Brunswick has a very good airborne LiDAR data set. And I think it's about 13 million or so points in this particular file. And, it's unfortunate you couldn't see the tool dialog, but, the inputs for it are effectively the LAS file input, or LAS file in my case, and then you can specify essentially a neighborhood that it searches, and that neighborhood can be dependent on the height of the tree. So if a point is higher up, then it'll search for a larger neighborhood and see whether or not it's the highest point within that neighborhood. And you can enter essentially a function for that. So this isn't yet in the 460 tools in the open core. It'll be in the next release. So I'll put it in the next release, and everyone can access that. And hopefully I'll have a few more tree or forestry based LiDAR tools for extracting some of those wonderful metrics. I was just looking at a paper of yours the other day from 2008 that you published with Wood and Trites that describes some of the forest metrics that are used, like dividing the range into 10 points and then a cumulative number of points within those 10 sectors. So I'd like to implement some things like that as well for the forestry community, and I'll put those in the open core as well.
Yeah, so very cool seeing this, and again, I know some of our listeners won't be able to see it, but we're looking at a GIS interface where we have some raster data from LiDAR, and John ran a tool to drop some points on the display. But just so I understand, John, with what I'm seeing on the screen is there's kind of like I'll try and describe it for our listeners, kind of like a folder navigation bar to the right, and there's a section called LiDAR tools, and expanded there's things like ASCII to LAS, there's colorize, to polygon, so or LAS to ASCII, or LAS to LAS, LAZ. So are these all tools that are in the open core, meaning like if someone was to download it, they're available to them now, or are these part of the paid license that a user would have to buy to access?
So the ones that you're looking at on the screen here, I would say probably about 95% of these are in the open core. Of course, my license on my machine has the extensions in there as well. So there are a few here that are part of the extension. Right. Modify LiDAR, which is a very powerful tool for modifying LiDAR point characteristics. That one's in the extensions. Filter LiDAR, again, pretty powerful tool. That one's in the extensions. But most of the ones that you mentioned, like for colorizing points, so for that one, you can input an air photo, and it'll assign the RGB values. It'll preoccupy the RGB values in the LAS or LAS file.
Very cool. LiDAR cool.
Digital surface model, which is what was used to create this DSM that we see in the background. That's also in the open core. Most of these are in the open core.
Yeah, very cool. Very cool. Yeah, thanks for providing that demo. And I know you mentioned at the start, you're looking at the LiDAR R package. So for those listeners, it's LID lowercase capital R. So this is again part of the R community, so available to others. I believe it was developed by or a shout out to Jean-Romain Roussel. I believe he was at Université de Laval. Doing some research there. Hopefully I didn't mess that up, right. JR, but shout outs to you on that side. But for those listeners, again, looking for some tools, there's that community, but as well, very cool, John, what I'm seeing on the screen. So definitely encourage people to Google your software and go from there. So thanks for that demo. I've got a couple questions as we look more forward looking, because I know looking at the Whitebox website, and given where today's world is, ChatGPT seems to be on every single flaming freaking post on social, anything from the Terminator, the world is coming to just have it right at the medical exam or the law exam to pass the bar, which I believe they're both successful in doing that. And then yet there's also stories where even some of my tests, the outputs are just terrible. They're nonsensical. So aside from AI, then with ChatGPT, with the large language models, the LLM worlds that are popping up, on the website, you talk about machine learning and AI. So I'm curious to know your views, because the listeners by now have probably concluded professor, super smart dude, hardcore developer, can code with the best because look at what he's produced. But at the same time, when I watch that, I'm like, professor, always thinking further into the future. And so I suspect you've got some crazy ideas or neat ideas on the research side in terms of how you can augment the platform. But what gets you excited about AI right now, and what does that mean for the Whitebox platform with the core open source side, the open core, and the commercial side? What do you see coming that gets you excited, and what are some of the things you can share in terms of work that you're doing right now that will come out in the next 6 months or so?
Sure. So, I mean, I wouldn't characterize myself as an AI researcher by any means, but I think as anyone in academics these days will tell you, AI is in many ways replacing many of the sort of more traditional ways of performing data analysis in academia in general. And I have sort of mixed feelings about that particular development in our area, and that's because of course, science is primarily about understanding, and AI is very much a black box model, which makes it somewhat difficult to be able to see why the system is what it is that it's picking up on, that it's able to see the trends that it is. But at the same time, the opportunities there are tremendous. And so we've been incorporating increasingly AI or machine learning really based tools in Whitebox tools. So we've recently released in the last year several classification tools that are based on random forest, KNN, support vector machines. So incorporating some of the machine learning based approaches. What we haven't yet incorporated is anything like a deep learning based approach to things. And certainly it seems as though some of the deep learning based approaches to solving some of the image classification, pattern recognition, LiDAR classification approaches is making headway, I would say for sure. I'm very interested in developing tools for LiDAR point classification using some of the machine learning approaches. So I will likely over the next year or so incorporate probably start off with random forest-based point classification in Whitebox tools. And that's where some of these point metrics that I've been developing, that I've been adding in, so they're sort of laying the foundation to serve as features into a machine learning-based point classification. And that's because point classification has traditionally been quite a challenging thing to get right with LiDAR point class, as I'm sure you're well aware. It's tricky for sure. And there are several sort of special cases that AI would sort of lend themselves very well to, like classifying power lines, for example, which is a problem that has sort of ticked me off for a very long time for various reasons related to my research. And so yeah, I'm excited about some of the opportunities that are presented in terms of newer technologies and being able to incorporate them. But ultimately, at the end of the day, nothing beats a really good algorithm. And that's essentially what AI is an attempt to have the computer develop its own efficient algorithm. But I'm old school. I've been doing this for 20 years, and I know that you take any one problem, like say depression removal from a DEM or flow accumulation, and there's a million different ways in which you could approach that problem. And the differences among them come down to like the efficiency of the algorithm, how well crafted it is, and how suited it is to an understanding of the uniqueness of the problem, not necessarily the data. And so I, have for a very long time advocated like smart algorithm development. And that's what Whitebox Tools really is. Instead of giving way necessarily to just the latest trends in AI, it's about trying to come up with the best heuristic algorithm that I can to solve particular problems. That's what I get really excited about. That's what I'm most excited about, coming up with more clever ways of solving particular problems. And I think AI has a space in that sort of general landscape, but I think overblowing its contribution is a major risk that we all have. But we may look back in 10, 20 years after this enthusiasm has perhaps died down with a little bit more of a balanced approach.
Yeah, for sure. I feel like we might have to do, instead of the AI versus human in a chess game or a Go game, it should be like the AI versus Dr. John Lindsay on the white box. Like, who can take this library and optimize it, and you only have an hour to do it and see what actually happens. I'd be curious to see what.
So as a little anecdote here, speaking of Chat GPT, so there's a researcher in Sweden who's a big Whitebox user, and he does a lot with AI, deep learning in particular. And so he tweeted a little while back that he was trying to avoid the hype of ChatGPT, but one sleepless night he couldn't take it any longer, and he logged in and he asked ChatGPT to write a poem about Whitebox tools, and it did. And he posted it on Twitter, and it's a good poem. Like it's a shockingly insightful poem that demonstrated that this software, ChatGPT, knows what Whitebox Tools does in a very intimate way, which was a little surprising to me.
Yeah.
I think put me in the camp of people who are a little apprehensive. I'm by no means a Luddite, but boy, AI is taking off in terms of its abilities to do certain tasks and to change society in ways that are a little scary to me. Don't get me started on what this means for university professors assigning homework. I don't even want to get into that conversation.
Well, there's startups that are developing countermeasures. I know there's one that leverages ChatGPT against itself to identify certain phrases or how they structure the AI structures response.
It's an arms race, isn't it?
Yeah, absolutely. That's what it came down to. It's crazy. So awesome. No, so definitely enjoy the time as we look to wind down. Thinking of folks who are interested in reaching out to you, because again, the beauty of it as being an academic, but also a foot on the commercial side, and you described well that you're not looking to be a Bill Gates or anything like that, but at the same time to really support the community, you need money to come in to ensure that you can grow and continue to do these great things that you've done. I'm sensing that if there's some folks that are listening to this that might want to reach out, whether with an academic problem or even hey, we're trying to do this type of processing, could we use Whitebox? I'm assuming you'll say like, heck yeah, just reach out and find me. But thinking of yourself and your co-founder with Whitebox Geospatial, what's the best way for folks to reach you? Is it social? Is it the website? Is it an email? What's the best way?
Yeah, I mean, all of those things for sure. So in terms of email, you can email me at the company. So that would be support@whiteboxgeo.com. And that's a pretty good way, particularly if you have general questions about the software. People do email my university account, which is fine as well. That's a good way of contacting me. In terms of Twitter, that's people reach out there fairly often, and LinkedIn as well. Those are generally the ways in which people reach out to contact me with interest in Whitebox or questions about how to use it, that type of thing.
Yeah, awesome. Very cool. I definitely appreciate the time and in joking, is this where I say, okay, for you listeners, for a limited time only, if you want to download the Open Core, you can use Kevin's promo code for free. Just use Kevin at the checkout. It's open source, people. It makes no sense. I'm joking, of course, but yeah, I thought it was more funny when I had it in my head. I was prepping to close out this podcast. But hey, I know you're a super busy person, so I definitely appreciate the time you've carved out for me to share with us the story of how the toolkit, the tool set, the open platform, the open core, the platform of Whitebox Geospatial, how the company came to be and all the cool things you're doing there. So definitely appreciate the time. For folks who want to reach out, as Dr. John Lindsay said, go through the email or support@whiteboxgeo.com. As Dr. Lindsay said, there's two of them, so you're going to get one of them and immediate support or a quick response. So thanks very much for your time, and looking forward to seeing you in person in the not so far future.
That's great. Thanks so much for the invite, Kevin. I really appreciate it, and it was wonderful meeting you at last. We've been circling around one another for a very long time.
For sure, 100%. All right, thanks, John.